We have made the decision to choose the topic of linear programming. To start with, we have made an introduction. It all began with the simplex method developed by Darting in the 1947. Linear programming is a mathematical optimization technique that's used whenever we want to optimize, minimize, or maximize any specific objective function. For example, it can be cost, consumer utility, or benefits or production of a company. It has been used in the oil industry, military as well, and also in the service sector and in the public sector of economy. Related to economics and business, it can be applied to transport problems, resources allocation, and production. To create a problem, we need two basic and essential elements. One of them is the objective function. This is the function we're going to work with in order to get the solution, and it's the one we're going to maximize or minimize in the problem. The second basic element is the set of constraints. Those are equations or inequalities, conditions that the variables of the problem must satisfy in order to get the right answer. We can also find two more structures, however, they're not essential to get the solution. Those are non-negativity constraints and graphical solutions.
Now we're going to focus on the case of Avellan. Avellan is an enterprise that was founded in 1911 as a family business dedicated to the manufacture, treatment, and handling of paper and paperboard products. So, although it produces many products, it now wants to maximize the weekly earnings of these three products: fish boxes, bottle partitions, and paper roll tubes. So, to produce these three products, it uses several components that are shown here with the respective function, and the first two are raw materials, whereas the next five are chemicals. So each of these components are used in different amounts depending on the product. The amounts of the components are shown here for each of the three products. And now with respect to the price, for each fish box that is produced, the selling price is €1.69. The board partitions are 16 cents, and the paper roll tubes are 6 cents. So with all those prices, we construct our objective function because we want to maximize the weekly profit. So X means the number of fish boxes sold per week, Y the number of bottle partitions sold per week, and Z the number of paper roll tubes sold per week. Of course, the enterprise has some limitations regarding storage that are shown in this box, and here are the different components and the limitation in storage. So with this and the other box regarding the different quantities of the components used for each product, we construct our 7 constraints. However, we also have to add the non-negativity constraints because, of course, the enterprise wants to produce at least one of each product, 1 unit of each product. So we use Excel and Solver to solve the problem. We put on the data, the different variables, the constraints, and we get to this solution over there where all the restrictions are respected, so it is feasible.
We are now going to analyze the result of Excel. If the company wants to achieve the goal to maximize the weekly profit, they should sell 1,978 units of fish box, 6,880 units of bottle racks, and 2,977 of kitchen rolls. By these measures, the company will obtain a weekly profit of €4,622.24. To maximize the production, the grounds of flocculant, starch, and imbo must be almost totally used. We can also indicate the products are not totally run out, like waste paper, water, glue, and deformer. Finally, it must be said that 11,635 units of finished products must be produced in the company so they can achieve their weekly profit. Due to this data shown on the previous slides, we get to the conclusion that the company should reduce the purchase of those materials that are left over in order to reduce the cost in production.